Greetings and welcome once again to Chennai Grades Online School. I'm Teacher Anthony, a specialist in chemistry and biology. Today, I'll be taking you through chemistry topical questions, specifically questions on periodicity. So let's start the first question. Question number 1. Define the following terms. Number 1, an atom. So what is an atom? An atom is the smallest part of an element that can take part in a chemical reaction. So that is what we call an atom. The next is element. What is an element? An element is a pure substance. That cannot be split into simpler substances by chemical means. That's what we call an element. Then we have a radical. A radical is a group of atoms. It's a group of atoms with a net charge and reacts as a unit. That is what we call a radical. For example, nitrate radical, hydroxide radical. These are some of the examples of radicals. They have a net charge. We also have ammonium ion, again being a radical. Then lastly, we have valence. What is a valence? Valence is the number of electrons an atom gains or loses in a chemical reaction. So question number 2, the atomic number of element Q is 17. Its mass number is 35. Determine A, the number of protons, B, the number of neutrons, C, the number of electrons. Lastly, draw the cross and dot diagram for the atom of element Q. So starting with the first question, the number of protons. We're told the atomic number of element Q is 17. Its mass number is 35. We determine the number of protons. So we need to understand that atomic number is simply the number of protons in the nucleus of an atom. So the number of protons in the nucleus of an atom is what refers to the atomic number. So question part A, the number of protons equals to 17. So we have 17 protons because the atomic number of that particular element or atom is 17. Part B, the number of neutrons. We also need to understand that the question says its mass number is 35. And we need to understand what is this mass number. Mass number, we know, is the sum of protons and neutrons in the nucleus of an atom. So here we have mass number as 35, protons are 17, then we do not have the neutrons. So mathematically we have 35 minus 17, and our neutrons will be equal to 18. So we have 18 neutrons. So the number of neutrons we can only determine by subtracting atomic number from the mass number. So we need to understand that. Next, we have determined the number of electrons. How do we determine the number of electrons in an atom? We also again need to understand the principle that goes that the number of protons in an atom is always equal to the number of electrons. So if the number of protons in an atom equals to 17, the number of electrons will also be equal to 17. So the number of electrons will be 17 electrons. So we have 17 electrons. 17 electrons. Moving to the next question, draw the cross and dot diagram for the atom of element Q. So now that we have the protons as 17, the neutrons as 18, we also have the electrons as 17. We can first have the electronic configuration for the atom Q. So electronic configuration, we are going to use the electrons to write the electronic configuration. So in this case, we have 17 electrons. We know that the first energy level in an atom carries a maximum of 2 electrons. So we have 17, so we have 2. The second one carries a maximum of 8, those are 10. And lastly, the third one also carries a maximum of 8 for elements whose atoms have less than 21 electrons. So in this case, we have 2, 8, 7. So to illustrate the cross diagram, in this case, we are going to use the cross diagram, not the dot. You can choose the two. You can choose either the cross or the dot. So using the cross diagram, because I have the protons and the neutrons, I'm going to have in the nucleus protons 17 and neutrons 18. I write the two, the number of the protons and neutrons within the nucleus, because I already have mass number and atomic number, therefore I can work out the protons and neutrons. From there, I look at the configuration and I realize that I have 3 occupied energy levels. So I have now to draw the 3 energy levels. How to draw the 3 energy levels? So the first one carries a maximum of 2, so we have 2 electrons. The second one carries a maximum of 8. And the third energy level carries a maximum of 7 electrons. So this becomes an atom of Q atom, which is 2, 8, 7. So when you are given or you are provided with the mass number and atomic number, this means that you write the number of protons and neutrons within the nucleus. By the time you find that you are not given the mass number, so you cannot work out the neutrons. So in that case, you just write the symbol of that particular atom or element within the nucleus. So in this case, if they had not provided the mass number, I could only have written the Q within the nucleus. Question number 3. Define the following terms. Roman 1, isotopes. Roman 2, relative atomic mass. So what are isotopes? Isotopes are atoms of the same element, atoms of the same element with the same atomic number but different mass numbers. For example, we have carbon 12 and carbon 14. When you look at them, they have different mass numbers. Carbon 14 with 14 as the mass number, and carbon 12 with 12 as the mass number. But the atomic numbers remain to be 6. So these are atoms of the same element, the same atomic number, but different mass numbers. Moving to the next question, define relative atomic mass. So what is relative atomic mass of an element? What is relative atomic mass of an element? Relative atomic mass is the average mass of an atom of an element compared to that of a 12 of carbon 12. So this is the average mass of an atom of an element compared to that of a 12 of carbon 12. I know it's not the first time that you are meeting relative atomic mass. In some questions, you find that you are provided with masses of certain atoms. For instance, carbon 12, magnesium, we have carbon 12, magnesium 24. We also have, for instance, aluminium 27. These are masses that has been predetermined through this or use of an instrument that we call mass spectrometer. By comparing the masses of those other atoms with that of a 12 of carbon 12. When you look at the mass of a 12 of carbon 12, you realize that is just 1. And that's the reason sometimes you'll find that definition being the average mass of an atom compared to that of one atom of hydrogen. Remember, hydrogen has a mass of 1. So when that particular instrument is used that we are calling mass spectrometer, and it weighs a certain mass against that of the standard atom. For instance, using carbon 12, 12 of carbon 12, meaning if I bring on board aluminium it will measure 27 times that of a 12 of carbon 12, and that will automatically be 27. 27 as the mass, relative atomic mass of that particular element. So in this case, we have aluminium. So for carbon, the same was done, magnesium, the same was done, and all other elements. That's how their masses were determined. So it is a relative mass, and this mass, when we are working out relative atomic mass, we do not include the units because it's mass that is relative. Moving to the next question. Lithium has two isotopes with mass numbers 6 and 7. If the relative atomic mass of lithium is 6.94, determine the percentage abundance of each of the isotopes. So solution, before we proceed, we need to understand that relative atomic mass has a formula that is given by R.A.M is equals to mass of the isotope, multiplied by the percentage abundance, of that particular isotope. Then you divide by 100. We are dividing by 100 because the abundance is in form of a percentage. So in this case, using this formula from our question, we are provided with the mass number. So in this case, the 6.94 is equals to mass of the isotope. We have the mass of isotope. Let me call it isotope 1. Mass of isotope 1 as 6 and mass of isotope 2 as 7. We are told to determine their percentage abundances. So looking at the question, we are not provided the abundances. So here we are going to say let the percentage abundance of isotope 1 to be X%. And automatically the percentage abundance of isotope 2 will be 100 minus X%. So in this case, I have to substitute in my question here or in my formula. I have mass of isotope 1 as 6 multiplied by its percentage abundance X plus the other isotope. I just use the same formula. This is the first one, then plus another. So I apply this formula twice because we have two isotopes. So this is just a formula of one isotope. So in this case, I will have 7 as the mass of the second isotope multiplied by the percentage abundance, which is 100 minus X. And then I divide by 100. So in this case, I just do the normal simplification. So I have 6.94 will be equal to 6x plus 700 minus 7x over 100. Then to simplify this further, I multiply both sides by 100. So I multiply this side by 100, and I also multiply this side by 100. So I cancel this with this 100 on this side. So I have 6.94 is equals to, allow me to cancel this with the 100 on this side, so that I have 694 is equals to 6x plus 700 minus 7x. So to proceed, I have 694 minus 700 is equals to 6x minus 7x. So to simplify this further, I have negative 6 is equals to negative x. So to get x, I divide by negative 1, negative 1. So x will be equal to 6. So by saying that, because I had let the percentage abundance of the first isotope to be 6, to be x, so in this case, the percentage abundance of isotope 1 is 6%. So percentage abundance of isotope 1 is 6%. So the percentage abundance of isotope 2 will be 100 minus 6. This one will be equal to 94%. This will be equal to 94%. And through that, we have worked out the percentage abundances for the two isotopes. So the only thing that we need in this question is to apply the formula that we use to determine relative atomic mass of isotopes. Through that, we should be able to get the percentage abundances of the two isotopes. So this marks the end of our presentation. If you found this presentation helpful for you, please subscribe to our YouTube channel, share this video to many students as possible, and as well subscribe to our YouTube channel, Shiny Grades Online School. Thank you for watching, and may God bless you.